We'll be looking at our math review 7-10, that's 7th grade, 10th week. We'll be looking at days 3 and 4. First, I will begin with day 3, the first subtraction problem of mixed numbers. We have 4 1/3 minus 2 5/6. You can do these on a different piece of paper and simply submit that paper. So 4 1/3. 4 times 3 is 12. 12 plus 1 is 13. 4 1/3 is equivalent to 13 divided by 3. Subtract 2 5/6. 2 times 6 is 12. Plus 5 is 17. We have 17 over 6. Now when we're subtracting, we need a common denominator. The common denominator between 3 and 6 will be 6. If the smaller number goes into the larger one, the larger number will serve as the common denominator. We could also use 18, but 6 will be a lot easier. 6 and 6. Well, 6 did not change, so 17 won't. You could consider multiplying both the numerator and the denominator by 1. Three times what gives 6? 3 times 2. Thus, we multiply the numerator by that 2 as well. 13 times 2 is 26. Now we have our common denominator. We can simply subtract the numerators. 6 remains the same. 26 minus 17 is 9. Now we can reduce. What number goes into both 6 and 3? 6 and 9, 3 does. 3 goes into 6 twice. 3 into 9 3 times. We have 3 over 2. Lastly, we can turn this improper fraction back into a mixed number. 2 goes into 3 once, with 1 left over. 3 divided by 2 is the same as 1 1/2. Going back to the problem and checking for reasonableness. Well, 4 1/3 is close to 4. 2 5/6 is close to 3. So we have roughly 4 minus 3, which is 1. So 1 1/2 is indeed a reasonable answer. You should now be able to complete the remainder of these on day 3. Okay, let's now look at percent problem number 2. Mariana raises $450 in February and then $360 in March. What was her percentage decrease? You may remember from previously, percent change. This is either an increase or a decrease. Is defined as the change divided by the original. So, in this particular problem, it said Marianne raises $450 in February and then $360 in March. What was her percent decrease? Well, the original in this amount will be February. Original is the first one. February clearly coming before March, so our original would be 450. The change is a subtraction. In this case, subtracting 450 minus 360 will find the amount of our what is clearly a decrease. 450 minus 360 is 90. 90 is our numerator. 450 our denominator. Alright. Well, we can do some reducing here. First, casting out these zeros. What we've done is divided by 10 on both the numerator and the denominator. So we now have 9 over 45. Well, 9 over 45 will reduce rather nicely. 9 goes into 9 one time. 9 into 45 5 times. So we have 1 divided by 5. All right. 1/5. That is our fraction decrease in this case. We've decreased by 1/5. Well, we want to convert that to a percentage. We hopefully remember that percent means per 100. Percent means per 100. Okay. So we will capitalize on that fact and convert 1/5 to a percent by writing it as a fraction over 100. 1/5 equals x over 100. Okay. We can, two ways we can go about this one. We can consider 5 times what gives 100? Well, perhaps you know it's 20. So 1 times that same 20 will yield x. Or we can cross multiply. 5 times x, 1 times 100. 5 times x yields 5x. 1 times 100 is 100. Now solving for x, we will divide by 5 on both sides. 5 divides 5, leaving x on the left. 100 divided by 5, that is 20 on the right. So x is 20. And that 20 is our percent. X is 20. This is telling us that we have a 20%, in this case, decrease. It went down. Decrease from February to March. Feb to March. All right. Perhaps that will assist with the other 2% problems. Although they are not percent increase or decrease, that the procedure may be helpful there. Now on to day 4. Okay. We have several dividing fraction problems. Remember our procedure. We will keep, change, flip. We will keep the first fraction the same, change the divide to a multiply, and flip over the second fraction. That is, we will be multiplying by the reciprocal. For example, looking at problem number 6. Pardon me, the 4th problem here that involves the 6. I'm looking at this problem. All right, we have 6 1/4 divided by 5/8. All right. Again, I will first convert my mixed number to an improper fraction. 6 times 4 is 24, plus 1 is 25. 25 divided by 4 is equivalent to 6 1/4. Leaving the divide the same momentarily, we have 5/8. Okay. Now I'll go with my procedure. Keep, change, flip. Keep the first fraction the same, 25 over 4. Change the divide to a multiply. Simply can use a dot for multiply. Flip over the second fraction. We have 8 over 5. Alright, now we're ready to perform a multiplication. What's nice about multiplication with fractions is we can simply multiply straight across. But first we can make it easier by doing some reducing. Any numerator can reduce with any denominator. 4 and 8. 4 goes into 4 one time, 4 into 8 twice. 5 and 25. 5 goes into 5 once, 5 into 25 5 times. Now we have the much easier multiplication of 5 times 2 is 10. 1 times 1 is 1. And 10 over 1 is equal to 10. Alright, now lastly we should consider reasonableness. This one's a little tricky with reasonableness. 6 and 1/4 is close to 6. 5 over 8 is close to 1/2. So we're asking ourselves, 6 divided by 1/2. That is, how many times will 1/2 go into 6? Well, another way to say that is in 6, how many halves are there? In 6 there are 12 halves. 1/2 will go into 6 approximately 12 times. Well, we see our result is 10. So our result is in the ballpark. That is a reasonable answer. Okay, one last problem from day 4. We have 2 at the bottom that are involving constant proportionality. You can check the previous video for help on this. Check math review video. Day 1 and day 2. I work one problem that is identical to numbers 3 and 4. I will now do this final problem. Andre lifts 350 boxes in 4 hours. It says Andre lifts 350 boxes in 4 hours. At this rate, can he lift in 10 hours? How many boxes can he lift in 10 hours? Well, a couple ways I can do this. I can find his number of boxes per rate by doing a division, 350 divided by 4, or I can employ a proportion and cross multiply, because this clearly is a proportional relationship. Alright, so I will begin with my word fraction. The two quantities we're comparing in this case are boxes and hours. I will make a fraction that says boxes over hours. I will now compare these two quantities with cross multiplication, with a proportion and cross multiplication. The first box and hours pairing is 350 over 4. 350 boxes over 4 hours equals how many boxes, so in this case are unknown to the boxes. I could put an X on top. I'm going to use B for boxes. How many boxes can he lift in 10 hours? 10 is my denominator. Let's verify to make sure our proportion is set up properly. We're examining boxes divide hours. 350 boxes in 4 hours. We want to know how many boxes. How many boxes? B. Can he lift in 10 hours? Alright. Again, if we can do any reducing in the beginning, it will be helpful. 4 and 350, well, 2 goes into both of those. 2 into 4, 2 times. 2 into 350 will be 175. Alright. This is another problem where instead of cross multiplying, it will be nice to consider simply what multiplier goes from 2 to 10. From 2 to 10, well, that's really nice and easy, 5 times. 2 times 5 is 10. So we can do the same multiplier in the top and save ourselves some arithmetic. 175 times 5 will be what B is equal to. Coming over to our scratch paper. 175 times 5. 5 times 5 is 25. Carry my 2. 5 times 7, 35, and 2, 37. Carry my 3. 5 times 1 is 5, and 3 more is 8. We have 875. So B is equal to, thusly, B is equal to 875. That is our number of boxes he can lift in 10 hours. Check for reasonableness. Well, 10 is more than twice 4, so 350 times 2 would be 700. 875 boxes does indeed seem reasonable. All right, one sentence in context. Andre can lift 875 boxes in 10 hours. All right. Now see if you can complete the other problems in the math review.